So welcome to our demo day today. Today we're going to be covering the RaySafe X2 system. And for our presentation today, we have our two panelists. We have Tom Kockler, he's Director of Sales at Technical Life Care, and Ed Brand, he's our Business Development Manager at Fluke Health Solutions. So Tom, I'd like if the two of you could go ahead and jump on and give a quick little intro about yourselves.
Good morning. Welcome to the RaySafe call. I trust we're all getting ready for a nice long holiday weekend. Like Dan said, my name is Tom Kockler. I've been actually working and selling the RaySafe product line for about 20 years now. At one point, I was a RaySafe employee until I ventured off to a different job with Technical Life Care as the sales manager. But my primary focus on a lot of days is the RaySafe X2 product line. So welcome to the call.
And I am Ed Brand, and I have been with Unfors and then RaySafe and now Fluke Biomedical, Fluke Health Systems for almost 20 years with Tom. And I started off as the director of sales for Unfors Instruments way back when we were a tiny company, and have stayed with it and had the progression of multimeters to the Unfors RaySafe XI and now the RaySafe X2, which is what we're going to focus on today. So I think without further ado, I think we're going to start up a video. Is that correct, Dan?
Yes, I'll go ahead and kick off this video for us.
Welcome. Today I'm going to show you the RaySafe X2 system. The RaySafe X2 system is comprised of a base unit as well as a choice of several different sensors. The most common sensor is the RF sensor. The RF sensor is used to measure on radiographic and fluoroscopic machines. It's also used to measure kVp on a CT machine, also kVp on some mammo machines. And last but not least, it's useful to measure on panoramic, cone beam CT, and intraoral machines. The next most popular sensor is the MAM sensor. The MAM sensor is used to measure on mammography machines. Then we have the light sensor. The light sensor is used to measure luminance and illuminance. The survey sensor, which is used to measure leakage and scatter. The CT sensor, which is meant to measure dose in a CTDI phantom, or it can measure dose in air also. It can also be used as a transparent sensor in case you want to measure scatter from a phantom. And last but not least, we have the newest addition to the X2 family. That's the X2 volt sensor. It's used to measure voltage. It can also be used with a current clamp to measure MA non-invasively. If I connect the RF sensor to the base unit, I use a USB cable. We have several cables available, 2-meter cable, a 5-meter cable, and a 5-meter extension cable. So any of the cables can be used to connect your sensor to the base unit or your base unit to your PC. And they can be used in combination. So for instance, you can use the 2-meter cable in combination with the 5-meter extension cable to get 7 meters, or you can use the 5-meter extension cable in combination with the 5-meter cable to get 10 meters between your sensor and your base unit, or your base unit and your laptop. So the first thing to do is power on the base unit. To do that, I just push the on-off button. The base unit will go through its boot up routine. Takes just a moment to initialize. And once it's ready, it asks you to connect a sensor to the base unit, and I will do that. There are 2 sensor ports. I can choose either of them. They're actually just USB ports. So you just connect your USB cable to the base unit and the other end to the sensor. And it automatically recognizes the sensor. In this case, I have the RF sensor. So it displays all the pertinent parameters that are associated with the RF sensor. So we have the KVP, the dose rate, the exposure time, the total filtration, the HVL, count pulses. It'll measure the dose per pulse, and last but not least, it'll count the pulse rate. If I put this in demo mode, I can simulate some exposures. So first I'll simulate a rad 100 kV exposure. So there you see in the upper left-hand corner, you have 101.4 kV, and next you see the dose, the accumulated dose, then you see the exposure time, the HVLs on the second row, as well as the dose rate and the number of pulses which it counted, which in this case is 1 because it's just a standard radiographic exposure. Then on the bottom line, we have the total filtration, the dose per pulse, and the pulse rate. Since this is not a pulsed exposure, those are just displayed as 3 dashed lines. All right, I will simulate a second exposure, and this time I will do a pulsed exposure. And now you can see that it's measured all the pertinent parameters. Notice also on the bottom here we have the dose per pulse and the pulse rate. Now you'll also notice the thumbnail representation of the waveforms. It's interesting if you're interested maybe in measuring you're looking at the waveform for KVP, you tap on that cell. That brings you into single parameter view, which is great if you're trying to read the display from across the room. And if you slide from the left to the right, you can look at the waveform. You can do some basic waveform analysis. If you tap the blue button, you can pinch and zoom just like on a cell phone. You can move the cursors back and forth. This to say, for instance, you're interested in where that peak falls. You can see that's 710.3 milliseconds. If I tap on this button again, it resets it. So the x-axis cursor is the time, and that is positioned at 921.9 seconds. That's where the dose rate fell below 50% for the last time because we used the full width half max definition for exposure time. And the y-axis cursor is placed where it's measuring the KV, and that we measure the average of the peaks for KVP, and that y-axis cursor is placed in that position. In this case, it's 100.6. There are 3 buttons on the bottom here of this base unit. This is the menu button. This is the home button, which brings you back to the home screen. And the back button, it takes you back to the last screen. So I'll push the home button to get us back to the home screen. And if you look in the upper left-hand corner, you can see that I've made 2 exposures. And this is exposure number 2 of 2. If I swipe down from the top, I can get back to exposure 1. swiping from the bottom to the top, I can get back to my second exposure. In the upper right-hand corner, you can see that there's the battery indicator. My battery is quite low at the moment, but that's okay. I'll simulate a third exposure, and this time I'm going to do a pulse low dose rate because I want to show you what happens when you can't measure a parameter. In this case, we can't measure KVP, or we can also not measure total filtration, and that is because the dose is too low. But how would you know that? If you just see the 3 dashed lines, you notice we have the I symbol, which stands for information. If I tap on that cell, it's going to tell you why you couldn't achieve that measurement. In this case, the dose is too low, and it gives you instructions on how to rectify that situation. It also shows you the specifications for that for this sensor. Go back to the home screen again. So I've done 3 of 3 exposures, and those are all stored in the base unit. So the base unit can store nominally 10,000 or data from 10,000 exposures. And that data can be transmitted to a PC using RaySafe View, and I can access that through the menu system if I want to just view the data on my base unit.
Thank you for preparing that video for us and going through that. And I'm going to turn it over to you on just to kind of go through the X2 system as a whole and get into some of the details, and then we'll get into some questions from our audience.
Yeah, thanks, Dan. So yeah, I showed you each individual sensor that comes with an X2 or that's available for RaySafe 2. But here it's just pictured as a group. So we have the survey sensor, we have the volt sensor, CT sensor, we have a light sensor, and then the 2 most popular ones are the RF sensor and the MAM sensor. And of course, you have to have a base unit to connect the sensors to. That little cable I showed you with the red colored cable, I think we got that as a question already. I was kind of monitoring, and that actually doesn't come with the system. This one I just got off of Amazon, but it shows that it can be used with any USB cable, and I like the shorter one for trade shows and for demos and things like that. But in practice, the longer cables are probably a better option to use for the situation of placing the sensor in the field and keeping the base unit at a distance where it can be readable. But that's the setup here. RaySafe X2. They can also available in systems, right? So we have packaged together certain sensors. We call them prestige systems, and then we offer a little bit of a price break if you buy a system with multiple sensors. So again, in the prestige configuration.
And that's correct. They do have the prestige kit, but you can start out a basic package with just the base unit. Say you want to just do the base unit with mass and the RF sensor. You can start with that product and just grow your X2 kit all the way up to all 6 of the different sensors. So it's whatever fits into your budget and your price range.
Perfect, thank you. And Ed, wanted to get into the design of the sensor. Can you share with our audience a little bit about the design?
Yeah, so for the RF sensor, which by the way, RF stands for radiographic and fluoral. Everybody on this probably understands that. It does not refer to radio frequency or anything like that. But no, it's so the RF and MAM sensor, which I actually have a MAM sensor here and the RF sensor. They're both designed with stacked diodes, right? So there's diodes that are stacked one on top of each other, and there's you can see in this photo here that there's filters in between. So it's like I'm dating myself now, but the old comic strip Dagwood, when he had the Dagwood sandwich, right? So you have a diode, and you have a filter, then you have another diode and a filter, and so on and so on. And they stack like that, and that offers huge advantages in positioning the sensor. You don't have to pay attention to the anode cathode axis anymore to minimize heel effect. The heel effect is in essence eliminated as far as measurement purposes with this sensor, actually with the MAM sensor or the RF sensor. Then you see that it's those filters and diodes are surrounded by a metal box, and that shields. You only want to see the primary radiation, so you only want to measure the primary radiation, not scattered. So that shields those sensors, so it doesn't measure any of the scattered radiation. If you want to intentionally measure scattered radiation, you can do so with the CT sensor. That is an ion chamber actually that's sensitive from all angles. So that's a good alternative if you actually do want to measure scatter, say from a phantom or something like that.
One thing that they did that was really quite different from the original RaySafe XI, and I'm sure there's a lot of XI guys on the phone call, is now they basically have two sensors, one for MAM and one for RF, radiographic and fluoral. And it really gives you a lot of options when it comes to, well, first of all, calibration. If your mammo machines and your mammo sensor has to be calibrated every year, which a lot of OEMs require that, you can just send in that MAM and continue working with your radiographic, your RF sensor. And technically, in a cost-saving world, which we're all in right now, you can share that MAM. Your physicist can come on site and have a MAM sensor, and you can share it. So there's a lot of different options when they split the sensors versus the old XI.
Mm-hmm. Good point, Tom.
Great, thank you guys. Let's go on to the next slide and talk a little bit about the accessories.
This one's right up my alley. So that flexi stand that we have in the very first picture, it's commonly known. When we first brought that thing out, it was a flexi stand, but it basically is a 30-centimeter stand as well. Okay, and for some of your C-arms and some of your X-ray devices, you want that 37 centimeter measurement. So basically, you can see I have my RaySafe X2 sensor in the stand, and now I can position this flexi stand on the table, and it's a precise 30 centimeters. Okay, the way they've got it set up there, if you want to get an in-air measurement, there's a coupler that comes with it, and you're gonna find this sand is gonna fit your needs. However you want to put it, however you want to place it, you can get it on your table, or you can get an in-air measurement if you want to use it for CT. The middle accessory there is the panoramic holder, and I think Ed, you got that on your.
I have one of those. That's my favorite because I've put a lot on. So I'm just holding it up here on my camera, and not sure how well you can see it here, but basically it's used to position the sensor. Sometimes it's difficult to position the sensor so that that narrow beam on a panoramic dental machine falls on the sensitive area. Even though the sensitive area of the RF sensor is very tiny, it's dashed, or that dotted, or I'm sorry, that solid black line there. But it's sometimes difficult, and this holder actually has a slot for GAF chromic film. And you can see I've used the GAF chromic film a little bit. You can see it's lined up over the dark area. So let's just say I did a rotation and that dark area was there. I just slide this and I bring this to the center. And of course, my RF sensor is placed here with the cable coming out the bottom. And then you just do your rotation on your panoramic machine and you'll get accurate measurements. You might have to go through an iteration or two to get it lined up properly, but it really helps. Sure beats tape, that's for sure. Even though tape is, if you don't have a panoramic holder, you can certainly use tape. But the GAF chromic film is a lifesaver.
And the holder, vacuum holder on the screen is basically to get your sensor or your detector or in air. Okay, so you can suction this to your wall bucket. You can put it on your table. It'll hold the sensor or the detector in place. But just real quick, I suctioned this to a wall one time when I was doing a demo, and it leaves a black mark. So you don't want to make the people in your hospital a little upset. You're cleaning people. Don't stick it on the wall, people, because it'll leave a black mark. But it did come off. I was able to get it clean. But this one is really nice for moving that holder around as well.
Reminds me of those shoes I used to have when, what is in the 80s or 90s, right? Those basketball shoes. Anyway.
Oh yeah, exactly.
So the one other accessory that we don't have here is this, it's a USB adapter. And people ask, you know, do we have wireless communication between the base unit and a PC? And the answer is yes. It just plugs into one of these vacant ports. So you plug the sensor into one USB port and just plug that Bluetooth adapter into the other port. And that'll give you wireless communication. You can see also that if you're using the RaySafe view, which is X2 view is being discontinued or being depreciated, and we're moving on to RaySafe view because it also works with our 452 survey meter. You can, if you're using RaySafe view, you can also use the Ethernet port to communicate with the PC. Just know that you'll have to change the IP address on your laptop, and you'll have to use a crossover cable if you don't have one. But that's now also open to our users to communicate with the PC.
And actually, real quick, I'm going to just mention the DXR Plus for you guys out there that are measuring light field to X-ray field. Ask your rep about the DXR Plus. It's quick, it's easy to use. Take a quick shot, and the diodes in there will show you exactly where that X-ray field is. The DXR Plus.
Tom is the master at selling those in combination with the X2 system. It's not it is not a component of the X2 system per se, but Tom always likes to promote that. So good job, man.
Yes, I do. Yes, I do.
What else we got, Dan? Do we have any questions?
We have. We're going to go ahead and kind of move into the Q&A section. We thank you, Ed and Tom, for kind of pulling a couple of those questions in as you're talking about the different accessories, and you know, that's a great way to keep engagement with our customers here. So I appreciate that. One of the questions is about exposures in gray, and they need to measure in Röntgen.
So yes, I'll take that one, Tom, if you don't mind. The X2 system, when it's delivered, we calibrate them initially, and they're manufactured over in Sweden, in a little suburb of Gothenburg called Bildal. Anyway, so they calibrate them in gray. So we usually deliver them in gray. But you can easily change the units of measurement to Röntgen. So you know, most times if you're looking at dose rate, you're looking at maybe microgray or milligray per second. With Röntgen, you can change it to Röntgen per hour, or I'm sorry, Röntgen per minute, or Röntgen per hour, depending if you're using the RF sensor or the survey sensor or whatever you choose. But yeah, those units can certainly are changeable. That's what I do when I get a new one. I just immediately switch it from gray to Röntgen because my head still thinks in Röntgen. Although we are moving, I think, quite slowly, but nevertheless moving to gray in the US. What do you think, Tom?
Absolutely. I mean, and you do get the question quite a bit from like a physicist or somebody that says, well, you know what, I'd like to actually measure both. And it's really super easy to switch it back and forth. Right now, you would have to take your measurement in Röntgen and then switch it to gray and take another measurement. But you know what, maybe we can talk the Swedes into automatically calculating that for us on the next edition. But it is very easy to work.
Great, thank you guys. Another question here. It's regarding the light sensor. Is it
Oh,
suitable.
I see the question, Dan. I think it's actually the DXR Plus. Doesn't it
No,
work?
it's the one before that, Ed.
What's that?
I'm sorry, say that again.
Why the DXR Plus doesn't work in fluoro? I saw that one pop up. It's because the diodes aren't sensitive enough. Yeah, there's a limit to the sensitivity of the diodes that we use in the DXR Plus. So they're great for radiographic exposures, and with mammo exposures, it works well, but you do have to use a high kV, high MA setting to get them. But for fluoro, the dose rate is just too low. So, we had considered, we still might consider making another version that's more sensitive, but so far hasn't been a lot of demand for that. But that is something that always comes up from time to time that we might consider.
Great, thank you. There was another question about the light sensor suitable for performing display luminance and illuminance tests according to the TG 270 standard. And how does it compare to the previous XI generation?
Well, as far as how it compares, well, technically, so the specs are that it's actually more sensitive in measuring luminance and illuminance. But how much more, I'd have to get back to that person with the specific, as far as with TG19, probably have to do a little more research on that. That's
great.
Before I could answer.
Yep. Sounds good. Yeah. Well, some of these questions may get a little higher level that we may need to pull a physicist in to help us out on.
I've been doing this for 20 years, but that doesn't give me a physics degree, does it, Tom?
No, it doesn't. One of the questions is easily answerable. It's all models of radiology for the fluoroscopy and cath labs. And as we mentioned in the video, once you plug that RF sensor in, honestly, guys, once you plug that RF sensor in for all radiographic and fluoro in your cath labs, for all X-ray machines, you are going to be able to get a measurement. Okay. Sometimes you're going to have to increase the dose, bring the detector a little bit, the eye closer to the sensor to get it. But once you plug that RF sensor in, you are going to be able to measure on almost every X-ray device out there.
All right, thank you, Tom.
I see one that says, once we connect our sensor to the base unit, it performs a self-test. What is that self-test? What if that self-test fails, and what can be the reasons? Well, the self-test fails, I guess what we do is we send a known current through these diodes, and we expect a certain response from that. And if we get it, it passes. If it's failing, most of the time when I've had it failed, which is extremely rare, but it has, it's usually due to significant temperature changes in a very, very short period of time. Like, I live in Wisconsin in the winter, leaving it out in my trunk of my car outdoors, and then bringing it in and plugging it in right away. That can create a sensor error, and that has happened just a couple times. You just let it warm up, simulate a little bit more toward room temperature, and that solves that problem. You do have to wait for the CT sensor to stabilize also, because there we're measuring, because that one is an ion chamber. It's not diodes, it's not solid state, it's an ion chamber. So that one you actually have to, even though we measure the temperature inside the chamber, there is a temperature range. So it's got to assimilate. It just takes a second or two to assimilate to room temperature. But the nice part about the CT sensor is that we do measure the temperature inside the chamber, which means that we're actually measuring the temperature inside the phantom. So, that thermal mass that you have with the CTDI phantom, you don't have to wait for it to assimilate to room temperature before you start making your measurements, because we're measuring the temperature inside that CTDI phantom. We're also measuring the pressure, but we do that in the base unit. So we automatically apply the temperature and pressure corrections as you would expect in today's world.
Great. Thank you, Ed.
The lowest KVP detection for the unit is the specs on the unit are 40 to 150 KVP. Okay, and that's at 1 millimeter of copper. Okay, for total filtration, it's 60 KVP. But yeah, there's some changes when we get into our solo versions, but the basic range is 40 to 150 KVP.
Perfect. Thank you.
KVP on yeah, of course, regular X-ray machines, fluoro, CT machines, you name it. In fact, the RF sensor for some of the machines, like I think it's the GE system, or is it the Hologic system, Tom? I don't remember anymore. I think it's the Hologic system that uses tungsten and copper. Yes, the Hologic system, they have that contrast enhanced mode, which is actually over the upper limit, upper KVP range of the MAM sensor. So for that, we can use the RF sensor to measure on a mammal machine. That's an exception, but it's yeah, it just shows the versatility of the RF sensor.
The last question is quite good. Do you need shielding plates for fluoro units? Okay, you know what? Honestly, guys, we're all at that point where some of us are a little bit 10 foot tall and bulletproof, and we think it's a real low dose on the fluoro. If you're thinking about shielding plates for yourself, yes, they need to be in place. We don't need to shield the X2 base unit or the RF sensor in place, but what I really like to do is, and I showed you that survey sensor that was part of the package. And for that person in your lab that thinks that, oh, I'm standing off to the right and I'm not getting any X-ray, hook up the survey sensor and just show him how much radiation is outside of that shield. And I'll guarantee you guys, they'll move back in line in a hurry. Your RSO will love it because your badges will never be out of calibration or too much radiation.
Perfect. Thank you, Tom. I apologize, guys. We're a little over time, and I appreciate everyone for hanging on. And we have some great questions coming in. And don't hesitate to email us back with questions. We'll try to get back with you as well to get your questions answered. Thank you very much for your time, and everyone have a great day.
Thank you.
Thank you. Thanks, everyone.